Okay, so our quiz is going to be on 12.4 and 12.5. So starting with 12.4. Remember, the first part is just an example of what we did in this section. So here we have our inscribed angles with our formula, and we have two theorems where if our inscribed angles share the same arc, then the angles are congruent. And if an inscribed angle subtends a semicircle, so here we have a semicircle, then this angle is a right angle. So now looking at number 1, we need to find what angle LMP and arc MN is. So starting with angle LMP, so we go from L to M to P. We have our arc is 36 degrees, so our angle is going to be half of that, so 36 divided by 2 is 18. Next, we're looking for arc MN. Our arc is twice the angle that it subtends, so it's going to be 2 times 48, so arc MN is going to be 96 degrees. Okay, going to number 2. So we need to find what the measure of angle GFJ is. So we start at G, go to F, and then J. So this angle subtends this arc, and we know that the angle is half the arc, so angle GFJ is 55 degrees. Next, we have to find what arc FH is. This arc subtends this angle, and our arc is twice the angle, so 36 times 2 is 72. So FH, arc FH is 72 degrees. Okay, next we have to find what X is. So here we have a semicircle, so this angle is going to be a right angle, and we know right angle is 90 degrees. So 5x plus 8 is equal to 90. So to solve for x, we're going to subtract 8 on both sides, so we get 5x is equal to 82. Then divide both sides by 5, and x is equal to 16.4. Okay, next, number 4. So we're looking for the measure of angle FJH. So we go from F to J to H. So here, both of these angles subtend this arc. So our two angles here, the one that's 5z and the one that is 4z plus 9, are congruent. So we set them equal to each other. So we have 5z is equal to 4z plus 9. Now to solve for z, we're going to subtract 4z from both sides. So it'll cancel out on the right side, and we're left with z on the left side. So z is equal to 9. Now we're looking for FJH, so we take our z and plug it in to 5 times z. So we have 5 times 9, which is 45. So angle FJH is 45 degrees. Alright, so these are the first 4. Okay, so the next is the second half of 12.4, which we learned about an inscribed quadrilateral, so a 4-sided figure that's inside the circle, and our opposite angles are supplementary, and supplementary means that they add to equal 180. So, looking at number 5, we have our opposite angles here, R and T, so we can add those and set it equal to 180. So we have 7y plus 11y is equal to 180. And now we're going to solve for y. So 7y plus 11y is 18y is equal to 180. Divide both sides by 18. So y is equal to 10. Now we can just take this and plug it into R, S, and T. So when we plug it into R, we get 7 times 10, which is 70. Next, we can plug it into T. So we get 11 times 10, which is 110 degrees. Next, we can plug it into angle S. So this is 8 times 10 plus 8. 8 times 10 is 80. 80 plus 8 is 88. So those are 3 of our angles. And next, to find angle V, we know that S and V are supplementary, meaning they add up to 180. So 88 plus angle V is equal to 180. So we can do 180 minus 88 to find out what angle V is. So angle V is going to be 92 degrees. So these are 4 angles of our quadrilateral. Okay, we're going to do the same thing for number 6. So our opposite angles are supplementary. So 10x plus 4x plus 12 is equal to 180. Now we need to combine the like terms to solve for x. So we have 14x, and we can subtract 12 on both sides. So 14x is equal to 168. Now we divide both sides by 14. And we get x is equal to 12. So now we can take this and plug it into angle A, angle B, and angle C. So for angle A, we have 12 times 10, which is 120. For angle B, we have 6 times 12 plus 3. 6 times 12 is 72. 72 plus 3 is 75. Next, for angle C, we have 4 times 12 plus 12. 4 times 12 is 48. 48 plus 12 is 60. So now to find angle D is opposite of angle B, so D and B are going to be supplementary. So we can do 180 minus angle B, which is 75. So angle D is going to be 105. Okay, next we have number 7. So first we're going to start with our 2 opposite angles here to find out what Z is. So our opposite angles, 2Z plus 2 and Z minus 17 are supplementary, so they add up to equal 180. Now we can combine the like terms, so 2Z plus Z is 3Z. 2 minus 17 is minus 15. Now we can add 15 to both sides. So 3Z is equal to 195. Okay, now we divide both sides by 3. So 195 divided by 3 is 65. And now we can take 65 and plug it into all of our angles. So starting with angle J, we have 2 times 65 plus 2. 2 times 65 is 130. 130 plus 2 is 132. Next, we can plug it into angle K. So we have 65 plus 25, which is 90. And then we can plug it into angle L, which is 65 minus 17. 65 minus 17 is 48. And then last, we don't have anything for angle M, but we do know that K and M are supplementary. And if K is 90, we're going to do 180 minus 90, and that leaves us with 90 degrees for angle M. Okay, and our last one, number 8. So we're going to start with our two opposite angles and add them and set them equal to 180. So 4x plus 5 plus 3x plus 7 is equal to 180. We're going to combine our like terms, so we have 7x plus 12 is equal to 180. We can subtract 12 on both sides, so we get 7x is equal to 168. And then we divide 7 on both sides, so 168 divided by 7 is 24. So x is equal to 24. Now we can take this and plug it into all of our angles. So starting with M, we have 4 times 24 plus 5. So 4 times 24 is 96, plus 5 is 101. Next, we're going to plug it into angle N. So we have 4 times 24 minus 10. 4 times 24 is 96. 96 minus 10 is 86. Next, we can plug it into angle P. So we have 3 times 24 plus 7. 3 times 24 is 72, plus 7 is 79. And then last, we're looking for angle Q. We don't have anything to plug it in to find angle Q, but we know N and Q are supplementary. So we do 180 minus angle N, so minus 86, and we get 94. Okay, so that was the last part of 12.4. Next we have 12.5. So first section of 12.5, we have an angle that is on the circle, and it has the same relationship as an inscribed angle, so the angle is half the arc, so this is our formula. And then we have an angle inside the circle, which we add the two intercepted arcs, multiply them by 1/2, and that's our angle. So number 1, we said our angle was half the arc, so we're going to do 216 divided by 2, which gives us an angle of 108 degrees. Next one, we're looking for arc LM. So we're looking for this arc here. So we need to know what this angle is, and we know that this angle plus 64 is going to add up to 180 because this is a straight line. So if we do 180 minus 64, we get our angle that we need, which is 116. Now when we go from the angle to the arc, we multiply times 2. So 116 times 2, which is 232. So arc LM is 232 degrees. Next we have angle JML. So we go from J to M to L. So our angle's inside the circle. So we take our two intercepted arcs, add them together, and multiply by 1/2. So 70 plus 52 times 1/2. 70 plus 52 is 122. 122 times 1/2 is 61. So angle JML is 61 degrees. And then number 4, we're looking for angle STR. So we go from S to T to R. So we add our two intercepted arcs and multiply by 1/2. So 99 plus 107 is 206. So 206 times 1/2 is 103. So angle STR is 103 degrees. Okay, so this was the first part of 12.5. Now the second part of 12.5, we have our exterior angles here, and we have the same formula for all of our exterior angles. So this is when the first one is a tangent and secant, the next one's two tangents, and the third one's two secants, but all the formulas are the same for each of those. So to find our exterior angle here, we subtract our two intercepted arcs and multiply them by 1/2. So we have 1/2 times 140 minus 74. 140 minus 74 is 66. 66 times 1/2 is 33. So X is 33 degrees. Next, number 6. Here it doesn't tell us what our second intercepted arc is, but we can find it because we know our whole circle is 360 degrees. So we do 360 minus the part that we have, which is 232. So 360 minus 232 is 128. So our second arc here is 128 degrees. And now we can just solve for X by subtracting our two intercepted arcs and multiplying by 1/2. So we have 232 minus 128 times 1/2. So 232 minus 128 is 104. And 104 times 1/2 is 52. So X is equal to 52 degrees. Next, for number 7, we multiply 1/2 times 75 minus 29. 75 minus 29 is 46. So 46 times 1/2 is 23. So X is equal to 23 degrees. And our last one, number 8. Here, it doesn't give us one of the intercepted arcs. That's what we have to try to find, but it does give us our exterior angle. So we have the formula for exterior angle, which we can just plug everything we have in and solve for X. So our exterior angle is 35 times, or it's equal to 1/2 times our two intercepted arcs subtracted. So we have 108 minus X. So now we just solve for x. So we can multiply both sides of our equation by 2 to get rid of this 1/2. So we have 70 is equal to 108 minus x. I'm going to add x to both sides, so I have a positive x, and subtract 70 from both sides. So the 70's cancel out, and I'm just left with x on the left, and 108 minus 70 on the right, which is 38. So x is 38 degrees. Okay, so this was 12.4 and 12.5 review. Remember, C period, you're taking the quiz on Wednesday. F, G, and J, you're taking the quiz on Thursday. Let me know if you guys have any questions. Just send me an email. Have a great weekend.